This is a bit of a departure from the rest of our videos. Over the next few minutes, I'm going to give you a lot of formulas. There will be just enough examples to give you some idea of what we're talking about, and no attempt at showing where these formulas came from. The assumption here is that you and the people watching this video have mastered these concepts in the past and are only here for a quick review. The object is to get you back up to speed so you can help kids cover these ideas in their homework. This is definitely not how you would explain these concepts to a child covering the material for the first time. When you first started learning about numbers, you almost certainly learned about addition first, and then subtraction, and then multiplication, division, and quite a bit later, exponents. Fractions are different in that respect. With fractions, we almost always start with multiplication because that is the easiest operation, followed closely by division, and even exponents come before addition and subtraction. Reciprocals. Reciprocals are the basis of pretty much everything we do with fractions. The definition is a bit technical, but follow along. For any real number except 0, that except 0 part is really important, there exists a number called the reciprocal, such that the product of the number and its reciprocal is 1. Once again, sorry about the technical language. The reciprocal of some number x can be written as 1 over x or x to the negative 1. These both mean exactly the same thing. X times 1 over x equals x times x to the negative 1 equals 1. So for example, 3 and 1/3 are reciprocals. 1/7 and 7 are reciprocals. 0.25 and 4 are reciprocals. 5 over 9 and 9 over 5 are reciprocals. And in each case, the product of a pair of reciprocals is 1. All non-zero real numbers have reciprocals. Even the irrational ones like pi. We will get into what we mean by real numbers in another lesson. Dividing by a number is the same as multiplying by its reciprocal. Before we go on though, let's quickly review the parts of a fraction. The numerator is the number on the top, and the denominator is the number on the bottom. To multiply two fractions, we multiply numerator times numerator and denominator times denominator, or put another way, top times top and bottom times bottom. For example, to multiply 2/5 times 3/7, you would multiply the numerator 2 times the numerator 3 and get 6, and you'd multiply the denominator 5 and the denominator 7 to get 35. To divide one fraction by another, you multiply by the reciprocal. Put another way, if the divisor is in fraction form, you flip it over, then multiply. For example, if you had to divide 2/5 by 3/7, you would change the problem into 2/5 times 7/3. Then you just multiply 2 times 7 and get 14, 5 times 3 and get 15. And your answer is 14 over 15. To raise a fraction to a power, you raise the numerator and the denominator to that same power. For example, 3/5 squared is equal to 3 squared over 5 squared, which is 9 over 25. Before we move on to addition and subtraction, we have one more concept to cover: equivalent fractions. Equivalent fractions have different forms, but the same value. You get equivalent fractions by multiplying or dividing the numerator and the denominator by the same number. For example, if we took 10 over 15 and we multiplied the top and bottom by 2, we'd get 20 over 30. That fraction is equivalent to 10 over 15. Or we could take the same fraction, 10 over 15, and divide the numerator and the denominator by 5, giving us 2 over 3. When we do this and get the numerator and denominator as small as possible, we say that the fraction has been reduced or is in reduced form. Now, if we have to add two fractions and they happen to have the same number on the bottom, a common denominator, all you have to do is add the numerators. So for example, 1/5 plus 2/5 equals 3/5, because 1 plus 2 is 3. We keep the denominator the same. To subtract two fractions with a common denominator, just subtract the numerators and keep the same denominator. So in this case, if we had 3/5 minus 1/5, that would give us 2/5, because 3 minus 1 is 2, and the 5 stays the same. This next part is probably not exactly what you were taught in school, but it does work. It always works. You can always get a common denominator by multiplying the numerator and the denominator of each fraction by the denominator of the other fraction. For example, let's say you had to add 2/3 and 4/5. Obviously, you do not have a common denominator here, but you could get a common denominator by multiplying the 2 and the 3 by 5, and the 4 and the 5 in the second fraction by 3. This would give you 10 over 15 plus 12 over 15. Now you have the common denominator 15, and you can just add the numerators. This gives you 22 over 15. This is an improper fraction, but that's perfectly all right for now. Multiplying denominators with this method will always produce a common denominator, but not necessarily the lowest common denominator. In other words, there may be a smaller number that would work as a common denominator for both fractions. When this happens, we will need to reduce our answer after we finish. Take a look at this example. We have 1/6 plus 1/8. Using our method, we get 8 over 48 plus 6 over 48. We add those two together, and this gives us 14 over 48. You'll notice that 14 over 48 can be reduced. In other words, there's a factor that goes into both 14 and 48, specifically 2. We divide 14 and 48 by 2, and we get 7 over 24, which is actually the lowest common denominator for this problem.